Hello and welcome back to VitoshAcademy. Today we are doing something extraordinary. We will be turning Excel into a pathfinding game engine using A-star algorithm. And if you have ever wondered how games calculate optimal path around obstacles, this is the magic behind it. Pretty much I will present two old Excel files. One old Excel file and one new, and I'll simply show how it works. For example, let's take a look. This is quickly showing the old version that I have done somewhere in 2015. We just click on reset. We make 300 obstacles with 20 rows and 70 columns. 70 is probably too much. Let's go with less. Yeah, something like this. And let's run to see whether there is a way. No way. Probably less obstacles, something like 100. Randomly reset and then run, and we found it. And what about some new obstacles just with selection like this? We reset and we see the blue from the selection, the green from not from the selection. Then we run again and we see quickly the red path. Just resetting and going with a 0 is also an option. And from here, what we can do is select this, reset, and then it would be quite an easy way, but this is Excel, so let's see. Just running from here, and this is how it works. This algorithm is the so-called A-star, probably the famous algorithm, and I have developed it. I have implemented. It's not mine. It's one famous guy. Probably Dijkstra is the name from Netherlands. So I have developed it. I have implemented it in 2015, and this was my first try. Somewhere in September 17th, 2015. This is how it looks like. And if you take a look here, you'll see that there are some issues and problems that I have probably not showed explicitly very well, but with this version here, they are obviously improved. And this version was the 20th of September 2015, so I had something like 3 days to fix it, and I did it. I was really fruitful in 2015. So back to the point, I'll put somewhere the whole Excel file. It will be without a password, so it will be okay. If you want to play with stuff here, it's kind of nice. You can change the number of columns. You can put something like 50 and 200, reset. You can say I want 1000 obstacles, reset. You can play a bit with Control Shift, and this is where the thing is. Okay, 1000 is not enough, probably 10,000 would be okay. Reset, 10,000 obstacles, quite a lot. And let's put more rows, something like 100. And let's reduce the number of obstacles, like 5,000, reset. Okay, this obviously has a way, so let's give it a start. And it already is running. Here the idea is that the orange algorithm are the ones that are checked. And if you take a look here, the ones that are not checked are with the style called currency. So we can wait a bit while I'm talking, and after some time we will be able to find the path. So thank you for waiting. For me it was longer, but the path is generated. I can zoom out and you can see that it is here, then there, and this is definitely the quickest path. and also it found it quite well. You see, as I mentioned, the orange ones are calculated and these ones are expected, so to say neighbors. Each calculated one has neighbors, and the neighbor cells are the ones that we would be able to calculate next for our next path. Okay, so far so good for this one. I mean, just running it once more, because probably you didn't realize how quickly the whole thing works, probably because of the number of obstacles. Reset. Let's make a few more obstacles here. I'm using Control D and Control R to make it. And let's block the way from here. And let's see which way it would choose. Okay, it found a quick way. Can we reset it? Yeah. In the next version that I'm having, I will also allow, like once it runs, to return back to the current version. Let's try again. Okay, that's it. Dijkstra has delivered something really quick. But what I'm thinking now is, wouldn't this thing here be quicker in general if we have gone like that? In theory, yes. In practice, let's see. Okay, so let's see the new one that I have developed. So what do we have here? Pretty much we have the following commands, and they will be given from VBA like this. I'll just make a bit more path, and there will be reset, main, make problems. Reset one is some predefined values that simply shows some kind of obstacles, and we have also reset 2 that goes like this. Okay, make problems. Making problems are made with control and selection. And let's try this one. Just clicking on main, and we see no path exists. If you want to check, you can see here the numbers. You see 10 are the real value, and 190 is the expected value to go to the green. So we try from A1 to K10. Let's make some path. And as I said here, what we can do is we can say reset and keep. So this is how our obstacles look now. Let's make some place here, and now let's run it. And the blue way is what we consider the smallest path. Let's take a look in the Project Explorer and go in the main and see what we can change. We can change a lot of things. We can change the playground. From A1, we can ask to be AA30. We can try with a reset, and it is now quite bigger. And let's put some random obstacles like this, just to see how it will look. Okay, make problems. Yeah, and now main. And it is quite quick. If you do not like the numbers here, what we can do is we can say that we don't want them by changing WriteScores to false. So reset and something like this. Main. Okay, this is what happens when you don't have obstacles. Make problems. And now reset and keep. And now main. See, it's really quick. I mean, it's even quicker, but it has to, of course, to draw stuff. So it works. What else can we do? What we can do is a bit interesting. We can play a bit. For example, let's try with this one. Reset and keep, for example. And now let's run main again. It's a bit good. It's really fast. That's what I like. And we can try to say, okay, for example, the straight line is 10 and the diagonal is 14. What will happen if we make the diagonal minus 14? Yeah. So in order to see what will happen with the results, I'll make sure that we write scores. So something like reset and keep is okay. And now run once more main. And you see that it is looking for some way that actually only goes diagonally, because diagonally we are getting points. Yeah. And if our diagonal was something like 140, you'll see that it wouldn't go diagonally at all because it's too expensive. Yeah. No diagonal because diagonally we are 140. What else can we do? I'll just return to 14 so it makes sense. Reset and keep. What we can do is we can change the goal and the start. So if they are not selected with GNS, they usually stay in the both corners, this one and that one. But in this case they are selected, so let's go again with main. And tada! It is selected, it's found, and it's obviously visibly the quickest algorithm. And it even told us path found and how much was the cost. And these numbers here that are available from the code, from this part, WriteScores true, we can change with 302, 312. What does it mean, 302? It means that when pretty much that 302 is the real calculated cost, and the anticipated cost to the goal is 10 more, so 312. And you can take a look here as well. 14 is the cost of the diagonal, the real one, and the anticipated cost when everything is okay, this is important, is 294 to go to this one. When everything is okay, I mean that the algorithm doesn't know about the obstacle here. So it calculates it this way. If you go to this one, you'll see 10. 10 means that the real cost from the start to here is 10. Not bad. Let's reset and keep once more and see what else can we do. If you want, we can delay a bit more the writing of the values, but you probably wouldn't like this one, so it's okay. Let's stop writing scores here and make a more interesting one. For example, something like this. If we do not write the goal, then the goal would be here, and this is the start. Yeah, something like this. And then let's run it. Tada! Quick as quick can go, in a way. Reset and keep is a good option. And from here we can have some kind of interesting fun. If you are interested in this one, it's an interesting type of fun. Okay, so let's see from here to here. So start, go, and let's run quite quickly. This is something that I would say. We have two methods for calculating the distances. They're called Manhattan is the first one, and the second one is called heuristic. And currently we are using the Manhattan one, but we can always change to heuristic. How do we change? We change in the code. So what do? Here we go to distance method heuristic. I will reset and keep and see with the same method what will happen. Well, I didn't write S and the other one, so it's my fault. So SG, and now running main, and we saw that this way we were looking for a lot more, but pretty much it found it. So far so good. Yes. What else do we have here? Let's see, we have the enums. I explained about the straight and the diagonals. About the make problems, the thing with the problems is that whenever we have selection and we click on make problems, it considers them to be the new problem. We reset with reset, we reset everything. We can have fun this way. If G and S are not written, then they are considered to be here and there, A1 and the one here. So make problems is what I was hoping for, and then main. You see, this way it was using heuristics, and it checked quite a lot of those. Let's change it to Manhattan and see what will happen. So dot Manhattan, reset and keep, and then main. Yes. Well, this way it didn't make so many checks. As you see, obviously, it was really way faster. So how does it work? Well, it's type of a greedy algorithm implementation, this one. So usually it goes and it runs. What is interesting here is that whatever you select as a path in the range, for example, let's say AN60, and if we say make problems and reset, and then some new problems, you see it's automatically squares there, and they work and they are nice. So yeah, let's try again with main, but I haven't clicked on make problems. So yeah, this is pretty much some interesting way of having strange fun in Excel, so to say. Yeah, found it, not a big deal for the extra implementation. And you see it's really fast. We can make this one already an interesting obstacle. Let's try again. Reset and keep. I'm just clicking here and I'm running this one, reset and keep, and then running with main, and it found it immediately. You see how many cells did it check here around. The purple ones are cells that are checked. These ones are neighbors, and the neighbors are the ones to be checked later. And as mentioned, the blue ones are the found path. So far so good. Let me know if you want to improve the code. What is a good option to improve the code is to make some kind of user interface actually, because almost no one that I know would even think about writing it from here. Something else is having a few more automatic random generator of mazes. This is something that can be implemented easily. So if anyone wants to do it, make a pull request in GitHub. I'll probably take a look, I'll approve it. And yeah, so far so good. I really hope you enjoyed this one and have fun. Goodbye. Ta-da!